Now it starts recording.
What's up, bro?
Does it record your voice?
Yes, it'll record my voice. And you can see me writing on it. You can follow the lecture along.
So now we just start over.
This would email me and say, please record your lecture today. You know? All right. Now, there are 5 d orbitals. 4 have a flower petal shape, but run in different directions. The last one looks like a p orbital with a donut around it. Is that right? All right. At energy level 4, the electrons occupy s, p, d, and what is the last one? F orbitals. These. So how many F orbitals do you think there will be?
Yeah, 6.
Oh wait.
7.
7. It will be 7 F orbitals.
Goes up by 2.
And they have a very complicated shape. You're not going to attempt to draw them. Okay, so there is this orbitron. All right, you can Google orbitron. My computer, it's not letting me permit to and show it to my students. All right, you want to do it on your phone? You know the shapes, the orbitals. You click on the side, and you'll be able to see the different shapes of the orbital. Now remember. So what is an energy level? An energy level is the distance from the nucleus. Is that right? So as the energy levels gets bigger, like 1s, 2, and so on, the number of seeds get bigger. The number of orbitals get bigger. Yes or no? And more electrons can go into it. Is it making sense? So all this comes from Schrodinger's wave equation, and they describe the probable region of space where you can find an electron at that energy level. Yes, you should click on the side. There is a side. Click like you see course materials on Blackboard. On the side, you should be able to see which orbital looks how. All right? Now, on a periodic table, are you with me?
Wait.
Yes, Sienna, what is the question?
Does like a single atom contain all of these?
Yeah.
Okay, so it looks.
It looks like this. It's a big hot mess that we can imagine. All right? And so, but these are the shapes of the orbitals, and this is how they are presented. This is how they're whizzing around the central nucleus.
So like, so all there.
They're all there. All right? Now, yes, Sarah. No, we don't know. Even I can't draw. So, how do we human beings talk about the atom, the electron, which results in all these chemical reactions? Is that right?
Yeah.
So then, if you look at the periodic table, and if you look at the very last electron, are you with me? The very last electron, where or which type of orbital is it entering? This is how it looks. The last electron enters the s orbital. Does that make sense? In this block, the last electron enters the p orbital. In this whole transition metal, it's entering the d orbital. And these two, it's entering the f orbital. Are you with me? So there is a pattern here. Do you see that? Now, so how do the electrons enter, or how are they arranged around the nucleus? Now remember, the electron will always like to enter the lowest energy level first. Stop doodling and watch me. Put that away. The electron will always enter the lowest energy level first. Are you understanding? Now, this is how the energy levels are arranged. It's 1s, there's a big difference, then there is 2s, then there is 2p, there is 3s, 3p. And then if you go further up, they'll start, this is how the seeds are arranged, so to say. This is how they will occupy the region of space around the nucleus. Does that make sense? We can draw that complicated picture, but if we put them like this, in order of increasing energy, this is how it looks. Does that make sense? So, the objective of today's class is to be able to write the electron configuration. What are we going to write? The electron configuration. Now, electron configuration is nothing but a fancy word for the electron address. Are you with me? We are writing the electron address for each and every electron that is in that atom. Do you understand?
Sounds like where they live.
Where they live. Where are they found outside the nucleus? Now, you do have a blank periodic table. Is that right? As a paper copy. Is that right?
Yes.
And I want you to do this on your periodic table. All right? Cross out helium. Write helium here in this area. Cross out helium and write helium there. Now, this whole block is called the S block. What is this? This is S block, meaning the last electron will enter an S orbital. Now, this whole block is your P block. This whole block is your P block. The last electron will enter the P orbital. This whole block, this whole block is your D orbital. The electron will be found entering the D orbital. And this last one is your F orbital. Are you understanding? So the four orbitals that they enter are S, P, D, and F. So how are you going to remember these orbitals? These are mathematical solutions like X, Y equals to. Is that right? So in order to remember, we are going to write a mnemonic. Silly
That's one.
people drive funny.
Fast. It's fast.
Fast also. You kids are going to learn to drive. All right? You kids will learn to drive, and that's how you will remember what the orbitals are. What are they? S, P, D, and F. Those come from the mathematical solution. Is that right? So that's how you remember what the orbitals are. Is that good? The next thing we should know is the energy levels. Now, the energy level for S always starts at 1, 2, 3, 4, 5, 6, 7. Those are the 7 energy levels for S. Now, watch me say this. You will get it too. S starts at 1. There is no 1P. Is that right? But then P starts at 2. So you write 2, 3, 4, 5, 6. There is no 7. Those elements haven't been found yet. Is that right? It's not labeled on your periodic table. Correct? So S starts at 1. P starts at 2. Where do you think D will start at? 3. Yes, this is 4, but this is 3. Don't think that is 4, so this should be 4. This is 3. So D starts at 3. 3, 4, 5, 6. Now, why is it like that? Because when they arrange the energy levels, because of the stupid weird shapes that there are you with me? So the energy level depends on how much the nucleus can pull the cloud in. Are you with me? The nucleus is positive, the electron cloud is negative. So 4s is lesser in energy, then it's 3d is lesser in energy than 4p. Do you understand? So the labeling has to be perfect. After 4s, what comes? 3d. And then S starts at 1, P starts at 2, D starts at 3, F will start at 4. So that's a 4 and that's a 5. Now, I'm going to give you 1 or 2 minutes. Let me see if you have memorized this. Can you please take your whiteboard periodic table and do this all over again? Can you please do this all over again? Label the XPDS block and number the energy level. Label the X, P, D, and X and number the energy level. No. Okay. All right. Now, guys, so let's look at hydrogen. Hydrogen has how many electrons? 1 electron. Is that right? So how will I write the electron configuration for hydrogen? Hydrogen is here on the periodic table. Is that right? So it enters which energy level? 1. It enters what type of orbital? S. How many electrons are there in that orbital? 1. So that is the electron configuration for hydrogen. 1s1. Now, helium is here. Is that right? So what is the electron configuration for helium? It enters first energy level, s orbital. How many electrons are there? 2. No more than 2 can enter an orbital. Is that right?
Right.
Now, let's go look at lithium. Lithium is right here. Are you with me? So I'm going to write lithium's electron configuration. Lithium has how many total electrons? 3. Is that right? So where will the first 2 electrons go? The first 2 electrons will still go into 1s2, but it has a third electron, which will go into what? It will go into 2s1. Lithium's electron configuration, its last electron, Sienna, will go to 2s1. Is that correct? Let's now write the electron configuration of beryllium. So, how many boxes are there? 1, 2. So, beryllium has how many electrons? 4 electrons. Are you all listening?
Yeah.
Are all eyes on the blackboard? Are you following along?
Yes.
Beryllium has 4 electrons. Where will the first 2 go? 1s2. Where will the next 2 electrons go? 2s1, 2. 2s2. Are you following along? So now I'm going to write the electron configuration for boron.
I think I see the
All right? Boron has how many electrons? 5. Is that right? Out of the 5 electrons, where will the first 2 go? 1s2. Where will the next 2 go? 2s2. Where will the last one go? Where is that? 2p. 2p1.
Oh my God!
Is this 2? Is that 3 orbital? How many boxes? 1. That means that electron will go into 2p1. Or it is occupying one of those p orbitals. Are you with me? Okay. Let me do a few things. Let's catch on to the pattern. So I'm skipping boron, nitrogen. I'm going to fluorine. Fluorine has how many electrons? 9. So where will we start? How do we start writing the electron configuration? Almost as if, everybody listen, they miss key details and then they're like, we don't understand. Because in between they're talking to somebody else. Shh. Now, how do you write electron configuration? You always need to start at 1s. Alright? And you go from left to right. Okay? I wrote 1s2. Is there a 1p? No. After that, I write 2s. And how many 2s? Maximum is 2. Now, what is the next thing I hit after 2s? 2p. And then I have to start filling out the 2p. So if I'm writing the fluorine electron configuration, it will be 1s, 2. 2s, 2. What is the next thing? 2p, but how many in p? 1, 2, 3, 4, 5. Is that right? That is fluorine electron configuration. Are we following? Okay, we are now going to do titanium, or let's do titanium. Titanium has how many electrons? 22. Alright? So how am I going to write titanium's electron configuration? Titanium is 22. Where do we start at? 1, S, 2. Then what is the next 2 electrons? 2, S, 2. What is the next electron? 2p. How many there? 6. Where do I come back again? 3s, 2. What is the next thing after 3s? 3p, 6. What comes after 3s? 4s, 2. This is very, very important. Everybody listen. What comes after 4s? What comes after 4s? 3d. This is 3. It is 3d, 2. Are you understanding? Do you understand it?
Yes, ma'am.
All right. All right. We are now. Can you go to this sheet, please? Can you go to this sheet, please? Are we in this sheet? All right. And let's look at the periodic table. Is everybody looking at the periodic table? Now, this is lanthanum. Is that right? What is lanthanum's atomic number? 57. What is the next atomic number listed? 72. So what happened in between? Do you see the break? Do you see the break in the periodic table? So after 57, where does it start entering? Does it go into the 4s orbital?
Yes.
So it ends at 71, and then it comes back and starts at 72. Yes or no?
Yes.
Okay? And your bismuth is somewhere here. Is that right? Bismuth is 83. So, how will I write the electron configuration of bismuth, which has 83 electrons? Okay? So, let me do the first few. So, it's going to start at 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. Is that right? Now, I am in 6s. Are you all listening?
Yes.
I need you to listen very carefully. All right? In my 7th period, I heard this from my students, and I love hearing such things. It makes sense. All right? So, these two are 6s, 2. Yes or no?
Yes.
After, there's a lot of chatter. I worry it gets lost in the chatter. After 6s2, yes, it does fill, this is 5d. Yes or no? It does fill 5d1, but I'm not going to do 5d1 first, because I know this is all getting filled in before it hits the 6p. Is that right? Instead, it breaks and it comes into the F orbital. Yes or no? So I'm going to say the next thing is 4F14. Because there are 14 boxes there. Yes or no? After 4S14, I'm going to say it is 5D10. Does that make sense? I included the lanthanum with the 5D10. Do you understand? And then now I'm in 6P, and what is it? 6P3. Because this almost gets filled in before the D starts filling in. Yes or no? There's only one electron that's filled in D, then it goes into the F. So I do not want to split this D level and say it's 5D1, 4F14, go back and say it's 5D9. I want to club all the D's that are in 5 together. And so I prefer to do it that way. Does that make sense? Okay? So now, again, 2 minutes and they start talking. There's another thing I need you to pay attention to. Does everybody have the bismuth's electron configuration written down? Please write that down. Make sure you have it. Please make sure you have it.
Wait, is that 5? Where 5? Where are you? 5. Yes.
Now, I'm not going to do bismuth, but I'm going to do an element that is in the F block. Are you with me? So, if I do an element from S block, let's say I do the neodymium. Neodymium magnets. Is that right? Neodymium is the element that's used to make magnets. They make very powerful magnets. Are you aware of it? Okay. What is the atomic number? 60. Is that right? So listen, if I were to write the electron configuration, I would do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. Now I'm in 6s2. Are you with me? So I'm in 6s2. 6s2. I do need to write the 5d1. I have to write the 5d1, and now I can write 4f1, 2, 3. If I do not write the 5d1, it doesn't count up to 60. And I will mark your entire electron configuration as being incorrect. All right? Because if you miss one electron, you are at a different element. Yes or no? As long as it's neutral.
Yeah.
Do we understand this? Can you write somewhere in the bottom that this is for an F block element and write this electron configuration down and underline and say the 5d1 needs to be there. Are we good? Do we understand this? Yes. DJ, what is it? We find that bismuth was too long of an electron configuration. We almost got tired writing out its electron configuration. Sienna is nodding her head very vigorously. All right, in total agreement. So what are we going to learn? We're going to learn how to write the abbreviated electron configuration. What does abbreviated mean? Shortened. All right? We're going to write the short version of the electron configuration. Now, include this word. The abbreviated electron configuration is also called the noble gas configuration. The abbreviated is also called the noble gas configuration. Now, you know, on a periodic table, this is your noble gases. Are you with me? Supposing I did not want to do all this. Let's go back to bismuth for a moment. All right. So bismuth had how many electrons? 83 electrons. Is that right? So bismuth is right here. Are you with me? So bismuth is in which period? It is in period 6. So this is how you write the abbreviated electron configuration. You should not choose the randon, but you should choose the one xenon that is in which period? 5. And what you do is, you write xenon in square brackets.
That's it?
After you write xenon, that's not it.
6.
When you write xenon, how many electrons have you accounted for?
54.
54. After 54, you write along and say, it's 6s2. Of course, it should be 4f14, 5d10, 6p3. Correct? It's so much more shorter. Yes or no?
Yeah.
Okay. Supposing I want to write the electron configuration of radium. Radium has how many electrons? 88. So what is the noble gas before it? Radon, followed by what? 7s2. That's it. Is that good? But can a noble gas be its own electron configuration? No. If you have to write the electron configuration of xenon, what should you start with? Krypton. Are we good? Are we good? Do you understand? So, can we try? Yes. Oh, you can leave. All right. So now let's try the electron configuration. Who's making all those noises? All right. Let's write the electron configuration of nobelium. Where is nobelium? What is its atomic number?
It is 102.
102. Let's do the electron configuration of nobelium. So nobelium, oh wait, let's actually try iridium first. My poor kid. Let's try iridium.
Where is
And
that?
I'll do nobelium with you.
Where is it?
All right? Iridium is 77 on the periodic table. Iridium is 77. So what will you start with?
Xenon.
Xenon. Very good. What follows xenon?
6.
6s2. Very good. Very good. Whichever kid said that. Very good. 4f.
Good job, Harry.
14. 5d. Is it 5d10? 5d.
6.
5d6. 22 plus 54 should be 77.
It's 5D7.
7? Does it add up? 1, 2, 3, 4, 5, 6, 7. Sorry guys, it is 7. Only then it adds up, right? Is that good? Are we understanding? Let's do nobelium. Nobelium is 102. So what is the last noble gas that we have on the periodic table that we can start with? Radon is 96. Is that 86? Is that right? What will come after radon?
7s2.
7s2. What will come after 7s2?
5.
5f?
5.
5f?
5.
14. Yes, well, it's not 14, it is 13. Is that right? Now this is incorrect.
Where'd you go? Where'd you go? 61.
Oh, yeah, 15.
Yeah,
Oh,
61.
no, you still need the 5d1. The
Yes,
16.
yes. So 7s2, you have 6d1, and then you have what? 5f13.
That's
Now, this is also incorrect.
What?
What? So why does chemistry become hard? Because I teach you something and then I will say there are exceptions to the rule. I hate that.
It's like the English language.
It's like the English language, all right? Okay, so let's look at copper. Let's go back and look at copper. Are you with me? So, if you want to write the abbreviated configuration for copper, how would you write that? You would do argon followed by what? 4s 2 3d 9. You know what? That is wrong. Why? Because how many total electrons can go into D? 10. P is 6. D is 10. Is that right? Now, many of the elements, now this is found in nature, guys. Remember, we get all our clues by studying nature. And we can only report what is in nature. It's been found that copper does not have this electron configuration. Copper actually has an electron configuration 4s1 3d10. Why does it have an electron configuration of 4s1 3d10? It's like, okay, there was 4s2 3d9. It borrowed an electron from 4s and became 10. Is that right? Yes or no? That which was in 4s got pulled out and got put into the d orbital. Yes or no?
Yes.
But when you look at the d orbital, can you say it is fully filled now? Is the d fully filled? Somehow, and then s is half filled. Yes or no? The S currently is half filled. Yes or no? Somehow, certain elements, which are the elements in the periodic table? So if you look at the elements in the periodic table, all right, the elements, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? These elements on the periodic table and these elements on the periodic table will all take 1 from the S and become D5 or D10. Do you understand? For some reason, they like to be half filled or fully filled in their electron configuration. Do you understand this?
Yes.
So, the class is almost about to wrap up. What I want you guys to do is, I would like you to answer all these questions. All right? For homework, do you have one additional sheet that says extra practice?
Yes.
I need you to do that as well.
Word 6.
All right? Always